Hi everyone, in this video we will be looking at solving simultaneous equations using the matrix method. Now we would have met solving simultaneous equations using the algebraic method back when we did algebra, and I know it was pretty difficult for many persons, and some students actually preferred this method, the matrix method, compared to using the algebraic method. You could decide for yourself at the end, right? So here's what we're going to look at, the general form first. This is the general form. If I have two equations, ax plus by equals m and cx plus dy equals n, we want to solve these two equations to find the values of x and y. So I will rewrite it over here, ax plus by equals m, and then cx plus dy equals n. So the matrix method is, first thing you need to do is need to pull out the matrix from those two equations. You're going to pull out a 2 by 2 matrix. The 2 by 2 matrix comes from the numbers or letters, in this case, before the x and the y. So the first equation, the letters are a and b before the x and the y, so that comes on the top. And then for the second equation, we have c and d before the x and the y. So that there is my 2 by 2 matrix. Then we always multiply by the letters we want to find, which is x and y. We want to work out what x and y are, right? And then that would be equal, is always equal to the two numbers at the end on the right hand side, which would be m and n. Now to find the value of x and y, just like in algebra, we're going to carry across what's next to the x and y and carry it to the right-hand side. Now, the opposite of a matrix, when you take it from the left side to or one side to the other side, it becomes the inverse of that matrix. So, the inverse of A, B, C, D multiplied by M, N. I know it's a little bit scrappy, but here it is, right? Now, it is a little bit confusing because it's only letters we're using here. Let's look at some numbers, which will make it a little bit clearer for you all. So let's look at this example here. Now, a warning, it's going to seem pretty long, but it is long. It's a lot of working, but it's not hard. That's what you need to keep telling yourself and you need to keep remembering, right? So here we have two equations. Solve the pair of simultaneous equations. We have 2x plus 4y is equal to 10. And then we have 6x plus 8y equals to 12. So I actually think, let me come up here, I'll do it right here. So we have let's pull out our 2 by 2 matrix. So pull out the numbers before the x and the y. So 2, 4, and then 6, 8, right? And then you always multiply by x, y, and that is equal to the two numbers on the right, which is 10 and 12 here. So that's our first part. You pull out the numbers to get your 2 by 2 matrix, multiply by x, y, and then that's equal to the two numbers on the right side. Now, x, y, right? Now, remember, now we just want to find what x, y is, right? So we need to move this matrix to the right side. So it becomes the s of 2, 6, 4, 8, multiply by 10, 12. Right? So now we have that. But now we actually need to work out what the inverse of that matrix is. So let's go ahead and work out the inverse. I'll change the color and let's do it at the side here, right? And you know how to find the inverse because you would have done that, right? So the inverse of the matrix, right, is what? Remember, the inverse is 1 over the determinant, and my determinant is what? 2. Well, firstly, actually, let's do it. Let's not do everything together so you don't get too confused, right? So I'm going to find the determinant first. So the determinant would be 2 by 8. Remember, the product of the first diagonal, take away the product of the second diagonal. 4 by 6. So my determinant is 16, take away 24, right? So we have 16 take away 24, and that would be that's my determinant. So now my inverse, remember it's 1 over the determinant, so 1 over minus 8 by the new matrix. So switch the first numbers in the first diagonal. 8 comes here, 2 comes here, And the numbers in the second diagonal, they stay put, but we just change the sign. So that's my inverse there. So let's go now and work on y. So I have 1 over minus 8 by 8 minus 6 minus 4, 2. So far what we did, we carried across the 2 by 2 matrix from the left side to the right side, but that becomes the inverse of that matrix. We worked out the inverse at the side, and now we're just going to go ahead and simplify this piece here in order to find our two values for x and y. So let's just get some space there. Right. So now leave this minus 1 on 8 here, and let's multiply these two matrices. Remember, when you're multiplying, row by column, row by column. This is a, I'll write this out so you could see it. This is a 2 by 2 matrix, and this is a what? 2 rows, 1 column, 2 by 1, right? So the numbers in the middle are the same. So we're going to get a 2 by 1 as our resultant matrix, right? Remember we did all that? So row by column, row by column. So let's go now. So now 8 by 10. So 8 row by first row by the column. 8 by 10 plus minus 4 by 12. And then minus second row by the column, minus 6 by 10 plus 2 by 12. And now we're just going to simplify. So xy is equal to, that is 4 by 12, yeah? And then minus 16 plus 24. Right? So now let's just come across here now. So xy is equal to minus 1/8. And then just work out what this piece is. Remember, plus and a minus that we have here. 80 plus minus 48. That becomes a minus, right? So we're going to get 32, 60 plus 24. Again, you could use the calculators for this all, yeah? Minus 36. Yes. So now xy, it will be equal to minus 1/8 times 32, and then minus 1/8 times minus 36. So our x and y values would be, for the top, again, I'll just use a calculator, and then we will get 4.5 for y. So x is equal to minus 4. Again, you could use this piece here, you could use the calculators, right? Alright, so we're going to do another one. I know it could be a little bit confusing, but once you practice, you will get the hang of it. If you want to pause this and try it on your own and then play when it after you attempt it, go right ahead, right? So, okay, let's pull out our matrix from the two equations. We have 5x plus 3y equals 5, and then 4x minus 3y equals 4. So my 2 by 2 matrix would be, the numbers would be 5, 3, and then 4. Here I have minus 3y, so it would be minus 3 here, right? And that's multiplied by xy, and that's equal to 5, 4. So xy is equal to the inverse of 5, 4, 3 minus 3, and that's multiplied by the 5, 4. Now I'm actually going to skip a step. I'm going to skip putting finding the inverse of this side. I'm going to do everything together, right? So you could try and do everything together as well. So the inverse of this would be what? The inverse of this matrix. So it's first of all 1 over the determinant. What will be the determinant? 5 by minus 3. Take away the product of the second diagonal. 3 by 4. Right? And then you just change up the matrix. So it's change up the numbers. In the first diagonal, minus 3 comes here, 5 comes here. And the second diagonal, you just change the sign. So it becomes minus 3, and this becomes minus 4. Then we multiply by 5, 4. So again, xy is minus 15. So this is minus 15. I write this slightly. Minus 15 minus 12. So this is 1 over minus 27 when you work it out. Again, you could use a calculator. And then we will get minus 3, minus 4, 5 by 5, 4. right? So now I'm coming on this side now. So now let me rewrite everything here so we could have it clearly when we're going to multiply now. So let's go. Minus 3 times 5 plus minus 3 times 4. Right? There should be a multiplication sign there. Let's just fix that. Right. So minus 3 times 5 plus minus 3 times 4. And then second row by the column, minus 4 times 5 plus 5 times 4. 4 minus 27. Minus 3 by 5 is minus 15. Plus minus 3 by 4 is minus 12. And then we will get at the bottom, minus 4 by 5 is minus 20. Plus 5 by 4 is 20. Just simplify x, y, 1 over minus 27. So remember, plus and a minus is becomes minus 15 minus 12, which will be minus 27. Minus 20 plus 20, that's 0. Right? And that is equal to 1 over minus 27 times minus 27. And then x, y will be equal to 1. Anything by 0 is 0. So the value of x is 1, the value of y. Right? Again, just using the calculators to work it out, right? Right, so let's do the last question here. Let's plot the 2 by 2 matrix. So 3 minus 2, see I put the minus, and then 5 minus 1. Right? We have minus y, so that's minus 1 times xy is equal to minus 2 minus 15. So xy is equal to the inverse of the matrix, right, times, yes, I know some people might prefer to do the inverse at the side, right? So you could do it at the side. I did the other one before together. So the determinant is 3 by minus 1 minus product of the second diagonal minus 2 by 5. So that will be minus 3 minus inverse. I could just do it right here one time. 1 over the determinant. And now I switch up the matrix. So the minus 1 and the 3 are going to switch. Minus 1 comes here, 3 comes here. And minus 2 becomes positive 2. And 5 is minus 5, right? And then we multiply by the minus 2 minus 15. And now let's multiply these two matrices here. So you get 1 over 7. So row by column, minus 15, sorry. And then second row, minus 5 times minus 2 plus, right? So let's go down a little bit just to get some space. So then we will get xy is equal to 1 over 7. Positive 2 plus 2 by minus 15 is minus 30. Then minus 5 by minus 2 is 10. Plus 3 by minus 15 is minus 45. So that is equal to 1 over 7. Here this becomes 2 minus 30, which is minus 28. And then here we get plus and a minus again, minus 10 minus 45, which is minus 35. And then finally it becomes 1 over 7 times minus 28 and 1 over 7 times minus 35. So we're really going to get minus 4 and minus 5. And truly, just a bunch of the different things we have done so far. Finding the determinant, finding the inverse, and also multiplication of matrices. All those things combined to find to solve simultaneous equations, right? Remember, you could always check back your answers by substituting the minus 4 and the minus 5, the x and y values, into the original two equations, and make sure you get your two answers, like minus 2, minus 15. Alright, so I'll see you all in my next video.